So we will now take a look at ratio, proportions, and percent. This is the next unit we're covering. So we'll start out to take a look at ratios. A couple of things about ratios. The first thing we'll do is reduce them into lowest terms. Talk about what they mean. So in this example here, I have what's described as 6 to 9, which means that 6 parts to 9 parts is the idea. So if you think of it like a mixture, if I was mixing oil and gasoline, that would be 6 parts oil for every 9 parts of gasoline. So I'd be able to double both and have 12 parts of oil for 18 parts of gasoline. Or alternatively, I can reduce the ratio into its lowest terms, which is what we're going to do here. Right, so if I think of greatest common factor and reducing fractions, well, I'm thinking about what's the largest thing that divides equally into both 6 and 9. And I can divide each by 3. It'll be hard to see my writing here, but you get the idea. I'm dividing 6 by 3 and 9 by 3. 6 by 3 is 2, 9 by 3 is 3, and we've reduced the ratio down into its lowest terms. So as you can see, it works just like a fraction, except for it's written sideways from left to right instead of being written as 6 over 9, which we will take a look at after. But the answer we're looking for here when reducing ratios is to get it into its lowest terms by dividing each by the same number, so a common factor. And ratios can also have 3 parts, because think of a recipe where maybe you have sugar, flour, water, something like that. You have more than 2 ingredients. Ratios could have 4 parts. In fact, I guess technically ratios could have infinite parts. And if we're trying to keep the ratio the same, we need to keep this mixture in proportion to itself. Okay, so, or in other words, the ingredients in proportion to each other. All right, and to do that, we'll look here at the ratio 4, 8, and 16, right? And so if we want to keep this thing in proportion, what we need to do is make sure that we're keeping the recipe the same. And the way to do that is to divide by a common factor. So if I think of the number 4, 8, and 16, the highest number I can divide each of those by is 4. So I will do that now, and when I divide 4 by 4, I get 1. Let's just change colors. 4 divided by 4 equals 1, 8 divided by 4 equals 2, and 16 divided by 4 equals 4. There it is. So our ratio in lowest terms is 1 to 2 to 4. We've changed the format of the mixture, but the recipe is still the same. Right, so a fraction can also be translated to a ratio and vice versa. You can write a ratio as a fraction. It's just important to keep the order in mind. So when I translate it over, 45 would be written first and 10 would be written second. And I could reduce either the fraction to lowest terms or the ratio to lowest terms at either of those steps. It doesn't matter which one I choose. So let's take a look at a different fraction. Let's say 36 over 8, say. And so the first thing I'll do is I will reduce this thing down. And so it looks like I can divide the top and the bottom both by 4, right? Okay, so 36 divided by 4 is going to equal 9, and 8 by 4 divided by 4 is equal to 2. So now I see that there's nothing else I can divide 9 and 2 by evenly. So now I can translate it directly to a ratio, and it's very simple. The top number comes first. Instead of a fraction bar, we write the colon, and the bottom number comes second. Our ratio in lowest terms is 9 to 2. We can do the same thing with a mixed number. Now, one common error that I see is someone will say, oh yeah, I remember 3-part ratios. Can I not just write this as 2 to 1 to 2, just like this, 2 to 1 to 2. That doesn't work. That is in fact false. That means 2 parts to 1 part to 2 parts. Over here, when we have a mixed number, this means 2 whole and a half added on to that. So these are 2 different things. So we have to make sure not to do that. So I'll get rid of that here. And let's go back and we'll make 2.5. So I've got this fraction. The instructions where I need to convert this to a ratio in lowest terms. So to do that, one way that I can start to move forward is make this an improper fraction. So 2 times 2 is 4, add 1 is 5 over 2. That's already in its lowest terms, can't be reduced. So I rewrite it as a ratio. It equals 5 to 2, and we're done. So we'll now reverse the process. We're going to take a look at 15 to 6, the ratio. So the instructions are write as a fraction in lowest terms and then a mixed number if possible. Okay, so 15 to 6. Either I can reduce it now and then turn it into a fraction, or I could turn it into a fraction, then reduce later. So what I'll do is I'll just reduce it here. I look at 15 and 6. I see the biggest thing I can divide both by is 3, and it's hard to read the writing that's small, but there it is. 5, 2, 6 divided by 3 is 2. So 5 to 2 is my new ratio. So I still haven't converted it into a fraction. It's very easy to do. If you remember, when we took a fraction, converted it to a ratio, we just wrote it exactly as you saw it. Same thing's happening here. 5 to 2 just means the first number goes on top, then fraction bar, second number goes on the bottom. The result is 5 over 2. Yes, that's right, but also the instructions said to write it as a mixed number if possible. So that is correct, but I should go one more step, and I'm going to say 2 goes into 5 twice with 1 left over. So there it is, 2.5, and that is the end result.